All right, in this lesson, we're going to start putting to good use those polyatomic ions that we've been looking at in the last few videos. We're up to 4 now. There's actually more than 4. There's about 20. And for now, you don't have to memorize them, but by the end of the year, you should have most of them down. So at the chemistry party, if somebody comes up and, kind of cute, you can impress them with your polyatomic ion knowledge. Now, today's comic, I'll bring it over. This is how excited you'll be once you are able to name compounds, all the compounds. You can see the ice cream truck comes and scientists are very happy. Alright, so here is a list of the polyatomic ions, and this is in your book, but this is a pretty comprehensive list, and you have a sheet for a quiz or a test that you can use this on. And the rules are pretty simple. In fact, you can tell if an compound, a molecule, it has a polyatomic ion because it'll have more than 2 elements. So for example, let's take a look at this one. Na2SO4. Okay, so we look here and we've got Na, we've got SnO4. So now, this is not a binary compound. We have the cation here. And now this is the anion. And it's a polyatomic anion, and they all have names. SO4 you should know as sulfate. So this very simply would be the compound name. Let's not do green. Let's do cyan. This would be sodium, and then SO4 is sulfate. Okay. So let's do one that has a transition metal, because the rules for transition metals, you still want to do the same thing that you did in the past. So let's look at this one. Alright, so when we're naming this, we look at the cation, which is going to be the first element, and that is Fe. That is a transition metal, and it is we can tell the charge of the Fe, right, by looking. Now, here's where it gets a little tricky. When you have a polyatomic ion, it has a set formula. So NO3 is nitrate, and it's always NO3. We put parentheses around the NO3, and then outside the parentheses we put how many, depending on the charge of the cation, how many of the NO3s we need. So you might be tempted, if you look at this, to write this as something like FeNO9 or something, like where you would multiply this 3 and so don't do that. This is not math. What this is saying is that there are 3 of the things that are inside. It's basically describing a picture, describing what a molecule looks like. So don't do it as it's a math problem. It's not. Anyways, there are 3 nitrates. And if we look at the charge of nitrate, we see that it is -1. So if we do our charge calculation, 3 minus 1s, this a -3 here, so the Fe must be a +3. So the Fe is a +3, so we name this as iron 3, and then nitrate. And that's the name of that. Now, there is one cation that is more than 1 atom, and it is this one. It's NH4 and it's a 1+. It's called ammonium. And if it's in a compound, it'll look like this. Let's say it's NH4Cl. Here you have to be careful. If you're looking at your chart of the polyatomic ions, NH4 is now the cation. This is the positive. This is the negative. And this would just be called, I'm a bad speller today, ammonia. No, that was right. Ammonium. And then chloride. So the rules for the cation stay the same. You give it the IDE ending. Okay, and one last thing to introduce this idea. when you're going from name to formula, so let's say, for example, that we had potassium. No, let's not do potassium. Let's do calcium. Calcium nitrate. So you're going to write the cation out. So calcium Ca with the charge. The nitrate, you can look at your chart and you can get that anion, and it's an NO3 1 minus. So now we're going to do the crisscross. Well, so we don't have to do the crisscross. What we can see is that, right, this is a -1, so we have to have 2 of these to make the compound happen. So the formula will be CaNO3 and then 2. But remember, we want to show that we need 2 NO3s. So to show that we need 2 NO3s, we put a parenthesis around the nitrate. And this is how, when using polyatomic ions, you write the formula. Now, take a second and I'll ask you this question and then give the answer as a last question here. Looking at this compound, calcium nitrate, how many oxygen atoms and how many nitrogen atoms are in that compound? If you said for oxygen and for nitrogen, you should have said 6 atoms and 2 atoms. And the reason is because you have 2 NO3s. So 1 NO3 is 1 N and 3 O's. 2 NO3s would be 2 N's. If we had a second NO3, which we do, we have 2 N's now, and we have a total of 6 O's.